This is the picture, this is the screenshot from our cycloslip. We group, and also this is the slide that we measure the performance of our satellite system, that how satellite vendors did their job right, and how satellite is performing okay if we have certified that the receiver is okay. So what this picture is, we group the satellite signals according to their signal strength, going from 0 dB to 50. This means this is the elapsed time, 10,800 seconds. During this 10,800 times, 10,800 seconds. During this 10,800 seconds, we had average of 5.22 satellites transmitting in this bin, and it accounts for 35.88% of satellite availability. At this period, GPS L1 had 35.88% of its energy, 50 dB or higher. 45% had at 10,798 seconds, had at 45 dB, and that accounts for 45%. So this slide you will see 35 and 45 is 80 and 97% of the time our signals were above 40 dB hertz. And this says we had one cycloslip, one satellite at this bin. So here we had no cycloslip, and in here, this says total number of cycloslips in all satellites. This is number of cycloslips per satellite, and this column is number of cycloslips per satellite per hour. So this is another indication that this environment was clean. And also this number, most important when you want to compare the performance of the satellite systems. GPS L1 get the score of 47.65 during this period. The same for the L2. Now we extended, say, let's do for the full day. For the full day, GPS L1 had one cycloslip, the full 24 hours, had one cycloslip at this bin, while total we had average of 4.95% satellite in this bin. So again, if you look for full day, no cycloslip here, one cycloslip here, 13 at this bin, and 15 on this bin. So here is at 35 dB, 1.25 cycloslips per satellite per hour. And it was 5% of the time. Don't look, this doesn't count because it was 5% we were in this bin. 35%, 34% here, 55% here, and all this, we had almost no cycloslip. Majority of 95% of the time, we had nothing. And GPS L1 gets the score of 44.98. Now we go to GLONASS L1. We compare, okay? Similar thing, 40%, 41%, 16%, again, similarly, no cycloslip. But GLONASS is 3 dB better than GPS. Of course, all this you can test yourself, and you can reset period to whatever you want, and we can also take the snapshot and we can send, as I will explain later, to any remote areas that you want. Now, GPS L2. GPS L2, because of, you know what, we don't get much above 35 dB because of encryption. So GPS gets the score of GPS L2, 31.24 dB. GLONASS L2, most of the time, is above 40 and 45. So similar, we have no problem in this area. These are in San Jose, and we don't have any problem. We can also get the same thing, combine GPS plus GLONASS and for L1 and combine GPS GLONASS for L2. Now, I want to show this to some mature audience, adult mature audience. GPS L1, GLONASS is 3 dB better. This one that I was campaigning, please don't do this. GLONASS is 10 dB better. Okay? Now, we say, we campaigned many years ago about selective availability. We were able to do something. Here, I just want to thank our Russian friends that we used to call them evil empire. They are giving us their satellite system free of charge, and they don't encode it, and they don't intend to put bomb any place. I hope my friend Gaylord was here today, that last year we had some heated discussion. I just tell this, all of you, when you leave here, please think. Please think. The policy that was made, it was pre-SA, and it was in the Cold War. They realized it. They finished it. They give us free of charge, 10 dB better. And no one in here said anything about this 10 dB. And then when Light Squared came and talked about 1 dB, the hell broke loose. 1 dB. GLONASS is 3 dB better on L1 and 10 dB better on L2 because they don't encrypt it. And then when I said, don't do this, they said something related to bombs or something. And at the same breath, they say high precision users account for $90 billion of things for our economy. Anyway, so this was end of discussion for what did I say? Adult discussion, mature audience. Okay, how to report interferences. We have this way, all the slides that you saw in here. It can connect to any one of our GNSS receivers through Wi-Fi. You can see this, that we don't have a good Wi-Fi in this hotel. Maybe we have to go through cable, but in this conference, we brought another hot point here. It works slightly better. In our office, works without any problem. Here, you can connect through Wi-Fi to any receiver anywhere in the world and see what is going on. This is one way, via Wi-Fi to Victor VS. Another one is from via Wi-Fi to NetView. NetView is a software that runs on any PC, and you can connect through internet to any receiver in the world and see all the information that I presented to you.